Hi everyone. In the last video, we had discussed about what a sequence is. So what we had discussed was that it is basically a mapping from a natural number to a real number. So basically, if you take a natural number, natural numbers are 1, 2, 3, 4, whatever, and then you have an expression with those natural numbers, and you plug those natural numbers into those expressions, and then you get a particular value. That might be a whole number, a natural number, it has to be a real number, right? So it's basically, in mathematical terms, we write it as this, that it is a natural number mapping to a real number. Okay, so so basically now we are going to learn a few things like limit, right? What is a limit, right? So suppose we have a sequence which is xn is equal to n plus 1 divided by n. So what the basic question here is that if n blows to infinity, suppose n is going to infinity, like n is increasing very very fast, so n is becoming 10,000, 1 lakh, 10 lakh, 1 crore, and eventually it's blowing off to infinity, what the value of xn will be. So we can think about this intuitively in a way that if n increases, then n will increase here too, right? So as n, if n is equal to 1, let's say n equal to 1, right? So xn is equal to 1 plus 1, 2 divided by 1, 1, 2, right? If we say n equal to 2, then xn is equal to 3 over 2, right? So we put 2 over here, 2 over here, 2 plus 1 is 3, 3 divided by 2, right? So then we say n equal to 3, then we have 3 plus 1, 4, 4 divided by 3, 3, 4 by 3 is xn, right? Now if we write it in decimal, we'll see it becomes 2, then 1.5, then this becomes 1.33. So slowly as n is increasing, xn is decreasing. And we can also think about this intuitively, that xn cannot decrease less than 1, because the numerator will always be greater than the denominator, right? So if n increases to like n equal to 10 lakh, right, then xn will be equal to 10 lakh and 1, which is that, divided by 10 lakh, which is like very 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 close to 1. So that's like this comes back as 1.00000. So this value will be very very close to 1, so it will be almost 1.0000001, right? So what happens, we all know what happens actually. So if I increase this 10 lakh to say 10 crore, right, so then we'll have another 0 here and then again 1, right? So it will keep on increasing, right, and it will keep on tending to this particular value, which is 1. So what we do in these situations is we define something called the limit, which I was talking about, right? So the limit of the sequence, so that is basically what happens when limit n tends to infinity of an xn, right? So that is the limit. And we also have a very gnarly definition of this limit, which no one really likes, right? I'll come to that too. So we have learned from basic calculus in our class 11 and 12 that if we take the limit of this particular xn, which is limit n tends to infinity n plus 1 over n, that is limit n tends to infinity 1 plus 1 by n divided by 1, right? So what we learned in class 11 and 12 in basic calculus was that whenever we have a limit that tends to infinity and we have polynomials, we just take, like, divide it with divide the numerator and the denominator with the highest power, right? So the highest power is 1, so we divide by n, and now this value becomes 0 as n tends to infinity, and the limit becomes 1. So that's what we had done by increasing n gradually, right? So this will come to 2, then 1.5, 1.33, and it will go on and get this particular value, and it will go on decreasing and then settle at 1, right? So that is the limit, right? So now we are going to talk about the definition of a limit. So this is basically the definition of limit of a sequence. So basically what it says is, suppose we take the previous example, right? So n plus 1 over n, and we got the limit of that particular sequence was 1, right? So suppose we take n as a really large number, right? So it should be a positive integer, right? So suppose we take n to be, say, 1 lakh, for just for the sake of the example. Now we put this in xn, so xn will become 1.00001, right? Now we take xn minus l. What is that? 0.00001, right? So what this definition basically says is that there has to be an epsilon. Epsilon is any random number. It can be as small as you want, but it has to be positive, right? So for any epsilon, right, for any epsilon which is greater than 1, this xn minus l mod, which is basically a positive number, so we can just basically say that this is actually a positive number, right? So for any epsilon, we can take an epsilon which is like epsilon is equal to 0.000001. So this value is less than epsilon, right? So this is what the definition is basically saying. So for any sequence, there has to be a limit L. For every epsilon greater than 0, there exists a positive integer n naught, such that for xn minus L mod less than epsilon, for all n greater than n naught, for any n which is greater than n naught. So suppose we take n naught as 100, so this holds, right? N is greater than n naught, and we just took this sequence, we found out xn, we subtracted the limit, which we actually found out by the calculus limit theorems, and we get that there can be an epsilon which is actually greater than 1, and it satisfies this particular a. So this is basically the definition of a limit of a sequence. So there are multiple questions that you'll have to do by this particular definition. It's a bit gruesome, but it's there in the syllabus, so we'll definitely have to do that. So I'll come back and show you some questions that we can do using this definition, and then I'm going to show you some questions we can do by the normal calculus method limits. Okay? Yeah. These are the two questions we'll do. So the first one, we'll have to prove by definition that this particular limit of this sequence is 2. And for the second one, we'll have to find the limit of this particular sequence with the calculus method, right, by dividing with the highest power and all, right? So we are going to go with the first question first, right? Okay. So there is a particular method of doing questions which we do by proof by definition, right? So I'm going to teach you that particular method. It's a really simple method. Okay, so yeah, let's just start. So basically we are told that the limit of the sequence is 2. So we're going to take L equal to 2, and we are said that sequence is 2n plus 1 divided by n plus 1, right? So we are going to use the formula, which is mod of xn minus L is less than epsilon, right? So we are just putting xn and L, which is 2n plus 1 divided by n plus 1 minus 2 mod less than epsilon, right? So this is going to become 2n plus 1 minus 2n plus 1 divided by n plus 1 is less than epsilon. So 2n plus 1 minus 2n minus 2 divided by n plus 1 less than epsilon, right? So this was the easy part. Now comes another easy part actually. So 2n and 2n is going to get cancelled. 1 minus 2 is minus 1, and the numerator mod will become 1. So what about this? So what we had told about the definition of a sequence was that it's a mapping from natural numbers to real numbers. So n has to be a natural number, right? So if n has to be a natural number, then n plus 1 also has to be a natural number excluding 1, right? Because n starts from 1 and goes up to infinity, n plus 1 will start from 2 and will go up to infinity, right? So 1 will get excluded. So n plus 1 will always have to be positive, right? So the mod doesn't really matter for this n plus 1, right? It only matters for the minus 1 on the numerator. Okay? So we are going to take this and we are just going to write 1 divided by n plus 1 less than epsilon. And now we are going to rearrange and get n as a function of epsilon. So this is basically the method that I am teaching you to do this type of sums, right? So this is positive, so we can just take it and cross multiply it, and we also know that epsilon also has to be positive and n is natural number, right? So n plus 1 is also positive, so we can just cross multiply. It's not a very big deal, right? So it becomes 1 by epsilon less than n plus 1, right? So we are going to go to the next step now. So n here becomes n greater than 1 by epsilon minus 1. So now we can take an n naught, which is the greatest integer function of 1 by epsilon minus 1 plus 1, right? So actually no, this is going to be minus 1, so that we can take n greater than n naught, right? So we basically take an n naught like this. So n is greater than n naught. So we can conclude that for any epsilon which is greater than 0, we will get 2n plus 1 divided by n plus 1 minus 2 mod less than epsilon. So hence we can prove by the definition that the limit of this particular sequence is 2. Therefore, hence proved. Okay, so this is a particular method that you will have to learn, right? So any proof by definition can be mostly done by this. There are some questions which are a bit difficult. I'm not going to go into that today. In those questions, you'll have a quadratic divided by a quadratic, and you'll see that it is not really easy to get n as a function of epsilon. So in those methods, we are going to take some approximations and we are going to just base it off, and we are going to take an n naught which will be a function of epsilon, so we can conclude in this particular way, right? So I'm not going to go into those questions today. I'll try to go into those questions the next day, and then we are going to go into the types of sequences basically. So now we are going to go to the second question. So what we are going to do here is just divide the numerator and the denominator with the highest power. So in this case the highest power is 2, so we are going to divide it by n square and n square on both sides. So it becomes n square minus 1 divided by n square plus n plus 1 whole divided by n square. So that gives us limit n tends to infinity 1 minus 1 by n square divided by 1 plus 1 by n plus 1 by n square. So as n tends to infinity, 1 by n square becomes 0, 1 by n becomes 0, 1 by n square becomes 0. So the limit of this particular sequence becomes 1. So this is the way of finding limits using calculus. So this is it for today's class. In the next class, we are going to go with the types of sequence, which are convergent sequences, divergent sequences, bounded sequences, monotonically increasing sequences, monotonically decreasing sequences, and then we are going to go into recursion and then close this particular chapter of sequence. Then we are going to go into series, right? So yeah, that's it for today's video. Thank you for watching.